this is our last lesson in this section, section 1.7. And then you're starting review before your first test. So the goal here is I can solve linear quadratic systems. Now, in grade 10, you solved a system of equations where both equations were lines. And we did this in the prerequisite skills, and you actually practiced that. Okay, now this time, this time and also in grade 10, when you solved a system, you were actually finding the point or points of intersection between the equations. Now, because we are doing systems between lines and parabolas, not just lines with lines, you end up with some different possibilities. So these are the three different possibilities. The one possibility is there's no points of intersection. Okay, in other words, you have a line, you have a parabola, they will never cross each other, so no points of intersection. The other possible solution is you have one point of intersection, and they actually call that one point of intersection, it's called a tangent line, so it touches just at one point on the parabola. And you'll talk more about tangent lines in grade 12. Okay, and the third kind is the line and the parabola intersects at two locations. Okay, so no intersection, one intersection, or two. Okay, so now there are two different ways that you can actually solve systems of equation. Obviously, one of them is graphing. Now, the reason I have arrow here is what are some of the advantages of doing graphing? Well, it could be less complicated. It could be. Um, but the problem with it is it's not very accurate. So it's not accurate, and so I'm not going to spend any time on it because you would have to graph the parabola, you would have to graph the line, and then hopefully they intersect at exactly one spot that you can read on a graph. So reading a graph is a little bit harder to do if the point of intersection is between the grid. Now, algebraically is much more accurate, so it's accurate. Some of the issues with it, however, are you could make some errors because of the algebra involved. So let's take a look at what we're going to look at. So we have a working example and it asks us to solve. So you can see we have two equations. Here's y equals the parabola and also y equals a linear line. So the first step that we would do is we would label both equations. So that's the first thing I'm going to do. I'm going to call this one 1 and I'm going to call this one 2. So very similar setup compared to when you did it in grade 10. The next thing I'm going to do is I'm going to substitute the line into the parabola. Okay, remember we didn't do elimination when we did prerequisite skills. The reason being is I knew that we were going to be doing substitution. Now when I'm going to substitute the line into the parabola, I have to make sure that I indicate this in my solution. So the first thing I need to do is I need to tell the person that is going to read my solution exactly what I'm going to do. So the first thing I'm going to do after I've labeled my equations is I'm going to say sub 2 into 1. And we're actually going to do that. So I have negative 10x minus 74 equals x squared plus 10x plus 26. All right, so then the next step is obviously I'm going to solve for x. Now, first of all, when I look at this, I have variable terms on both sides. I have numbers on both sides. So first of all, I need to get everything to one side so I can solve. Now, so we're going to do that first, and then we'll talk about how we're actually going to solve whether it's factoring or quadratic equation. So bring our pen again. So I'm going to have 10x squared. When I add 10x to both sides, I end up with plus a 20x. And I'm going to add 74 to both sides. So I end up with plus 100 equals 0. Now, I am left with a quadratic and a quadratic equation because it equals 0. So I want to solve for x. So I'm left with two choices. I can either factor if I can or quadratic equation. I'm going to try the factoring first if all possible because that will take less time. So when I look at this, I have a perfect square and 100 is a perfect square. If I take the square root of this one, which would be x, square root of that one is 10. So that's 10x. And so I'm looking times 2. Will that give me my 20? Yes, it will. So I'm just going to get rid of that for a second because that looks pretty messy. So I know it is a perfect square. So I have x plus 10 squared equals 0. Now, remember, we're solving for our x, so that means I would set it equal to 0, and I would have 10x plus 10 equals 100. Oh, sorry, x plus 10 equals 0, and x equals negative 10. Now, I'm not finished because this question didn't ask to find x, it asked to solve it, which means the point of intersection. So I have where they intersect. They actually both intersect at negative 10. So the next step I have to do is I have to substitute this x that I found into, in most cases, the linear equation because it's going to be the easier equation. But again, I must make sure that I indicate this in my solution. Okay, so what I'm going to do now is I'm going to tell whoever is reading my solution that that's what I'm going to do. So I'm going to say sub x equals negative 10 into my line, which was equation 2. So I end up with y equals, it was negative 10, and the x I found was negative 10 minus 74. So again, it's just a matter of actually doing the calculation. So I have 100, take away 74, which would be, I have 64 here, but that is wrong. Just hold on. Sorry about that. Which would be 100, take away 74, which would be 26. So I'm almost finished. I have one more step to do, and the step is I need to put a therefore statement that contains that ordered pair because that is the actual solution. So what we're going to do is therefore, and you don't have to actually put anything other than therefore and then the ordered pair. Negative 10, positive 26. All right, so that's not too bad. Now what I'm going to do is I'm just going to stop this video and create another one because I can find something else. I can find out how many intersections there will be without going through this whole process. Can you imagine going through this whole process, even using the quadratic equation and then finding there were no real roots? And if I found there were no real roots, that means that there was no solution to my system. I'd be a little upset because I could spend, half a page coming up with this solution and then find out there is no solution to the question. Okay, so in other words, the answer would be no intersection. So that's what the second part of the video is going to show us.